This is the function. Function call is here. So we know that we can send any object, even we'll send functions also later. Now suppose you consider a list here. We'll separate all this. And then you write A, B, C, D, E here. So if you want to send 5 arguments here, you need 5 variables here. Then you can write this is A plus B plus C. Suppose I want only 3 or 4. D, whatever I want. Okay, no problem. Then you write a print statement, print F here. So if you run this program, okay, there is a problem here. 0, 5 were given. Yeah, who can say what is the problem? Anyone?
The name of the function is not correct.
Name of the function is not correct. Tell me what I need to change here.
Sir, we have defined fin whereas we are calling fun.
Okay, fine. So here we added these numbers 10, 20, 30, 40, 50, and we got 150 here. Now we can add all these numbers this way. Now suppose these are called positional arguments. Positional arguments means the first one will go to the first and the second one will go to the second. If you want individual, you can print and check. The last one will go to the last. So sometimes if you by chance, by mistake, if you write this way, I was counting these two. See, it says there is a problem. Now suppose you have 2 and you want to send 10 to B and 20 to A. So then you have to write here B is equal to 10, A is equal to 20. In that case, what will happen? So here even I can write print A here. So if you check, A is 20 here, though A is the first one. Because using keyword, we have written A is 20. So these are called keyworded arguments, okay? Positional arguments means from position to position. First position value, whatever we have given, that is called argument, that goes to the parameter, the first parameter, and the second one goes to second parameter normally. However, if you want to be sure that I mean you don't want to see the order and you are comfortable writing the values here itself, yeah, you can write that also. It's not a problem. So here we don't obey the positional thing, okay? This is one. The next one is, suppose I have so many values 10, 20, 30, 40, 50, and I don't want to write all these parameters like 5 or 6 parameters. I can take everything in A. For that you have to write a star here. So normally people start writing ARG, but yeah, you can write anything. What you need to write is star here, okay? If you print A here, but remember it's a iterable, I mean it's a tuple. If you print here, you get in the tuple form 1, 2, 3, 4, 5. If you want to get individual one, you can write a for loop. So I printed this 5 times. I have to write I here. So if you print A, so what we have done is we sent all these numbers like 10, 20, 30, 40, 50 to A here. And then we wanted to print A here, okay? So whatever way you send, that's a separate thing, but it will go to A, and then you can print one by one, and you can get it directly. Also, you can print here. Yeah, you sense here. Okay, old questions. Now this star you have to write. Now my question is, suppose I cut this one, will it work? It says takes one positional argument, but 5 were given. So it can take only one, but you have given 5. Now suppose I give this way. I'll make whole as 1. Because what we are sending here, we are sending objects. So tuple is object, list is object, function is object. I can send a function also here. I can send one number. I can send one string. I can send a dictionary as well. So I want to send this, okay? This is possible. See, I got it. Suppose I write a star here now. What is the difference between writing a star and not writing a star? Now see the difference. When you write a star here, this is considered as the first element of the tuple. Ultimately, remember, let me write here. We write this way. Star, when you write, this takes many arguments, many and makes a tuple. Now, when we say this, it will make a tuple. That is the only difference. Suppose I'll write another one here. Even if you want, you can check it. You can send a list also. See, I got a list. I will write another list here. I got another one. So ultimately you get a tuple. This is considered one element. This is considered another one. Okay. So two elements we have. So we are sending to A. So what are the constituents of A? Not numbers. So if you cut everything, suppose here, I cut this one and this one. Now you print length of A. Check here, length of A. Print is required or not. So 7 here, right? Now suppose I make this. So this is considered 1. Even you print A as well. Because if you print A, you will be able to know See, print A here. A is 7. Okay. Sorry, A is this one. And number of elements 7 here. Because if you have written a star here to the left, it has the capability to take everything at a time. Everything, when I say, how many you need to know? Here 1, 2, 3, 4, 5, 6, 7. And see, all the 7 are numbers here. So this is 1, this is 2, that way. And the whole is a tuple. See, this tuple, the left parenthesis of the tuple is this one, and the right parenthesis of tuple is this one. So within this tuple, we have elements here, one by one, whatever we have sent. So now if I just make a list here, that means I'm sending one list. So if you make a list, I'm not sending 7 numbers, I'm sending 1. So you run it, you see length is 1 here. So if I send another one, 56, not necessarily a list, what will happen? See, the second element of the tuple is a number. It's no more a list. Remember, in Python, a tuple can contain a list. The first element is a list, second element a number, third element a string, whatever you want you can do, not a problem. Okay. So the star, if you write to the left, it has the capability of taking everything, whatever you write here. So if I make another list here, so what will happen is this A will take 2 here, not 1. This is 1, this is 1, 2 here. It's not even 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not 9 or 10, it's 2. Okay, that's why I've written length of A. So you see here, it's 2. If I write this, it's 1, 1. Now suppose I cut this one. Will it work? Yeah, anyone who can answer? Suppose, yeah.
Yeah, it should work, sir.
Yeah, it should work. Okay. Suppose I write Amit. So this is a string, and length of the string, length is a function in string, you can check. So it gives 4 letters. It's a string. Okay. And if I want a number here, just a minute. I have to see, there is a problem because we were counting length. Okay. Here 10. Okay. Control Z. So you can send a number here. You can send a string also. Then you can send a list also. So list as a function called length. So you can find the length. Length is 7. But if you make it star here, this will be 1. That is the difference. So suppose I write this way. It's not allowed. It's not allowed. Even you can send it this way. It's not allowed, right? Because now A can take only 1. But here we have so many. 1, 2, 3, 4, 5. That way we have so many. It's not 1. So A can take all this. We need how many arguments? Here, how many arguments here? That many parameters we need here. 1, 2, 3, 4, 5, 6, 7. We need 7 here. But here, if you make it a list or tuple or even a set, here it's not 7, it's 1 object. We are sending 1 object. Even if I write more here, then it will create a problem. Suppose I write AB and I write this one, then it will create a problem. It's a problem because we're sending 1, you have 1 here. Okay, we're sending 1, you have 1 here. Unlike other programming languages, suppose you will send it's very funny, we send a list here, or maybe you send a number here, But then you change it to a string here. That's also possible. Okay, here you change it to Amit here. Then a list type, it changed to a string type, duck typing. I'm not going to that. A string type can be, because we are not defining its string or whatever list. Anyway, that's a separate thing. I'm not going to that now. Here you see, we are sending one, but we have two parameters. You see here, missing one required positional argument. Okay. So what will happen is this 1020 you have here. Okay. That requires only one parameter, not two. However, if you cut this, now we have two, so you need two. This is one. Fine. All right, let's go back to this one. Now this is one, so one is sufficient. We don't need two here. This will work. Okay. Now suppose I will write this way only. This is one, and I will write a star. What will happen? This is my question. It's like, if you want to see a better version, I can give you this one. Only 10. Then what will happen? Because we say A is the capability of taking many objects. If you write a star to the left, but I have written only one, then what? Will it work? If it will work, then what is the difference between this writing and not writing? Suppose, let me write here, because in number we can do that. So you write here. See, finally, whatever objects you are sending to A, all the numbers, it will be counted. Length of A, that is 1, because this is the first element of the final tuple. I've written tuple here, you see. But if you are not writing star, it will not make a tuple. Whatever you send, that only. Okay. So length will be 4 here, because this will be considered as 1. See, length is 4 here. Because if you print A, you are getting Amit and no tuple here. See, tuple formation is not happened. You are not forming a tuple, because we don't have a star here. So you have to think it properly. Now I've written a star. Okay. Then I'm sending this one to this. So then what will happen? You count how many objects you are sending. Not 4. You are sending 1 actually. If you write this way, it will be 4. But now we have one string we want to send to A. Okay. So then also it will work. There is even if I write 10 also, it will work. It's not a problem. 1 or more. Only 1 means you don't write a star. 1 or more means you write a star. 1 means it's okay, no problem. 1 you get. You write 20 here, then also it will accept. 2 here, then 3 here, then 4 here. So many arguments it's capable of taking. If you write a star to the left, you need not write 4 arguments here. However, what I'm saying is, if you make everything a list, this becomes 1. You don't need a star here. These are not 4. You write a list, a tuple, or a set, whatever you write. You can check. See, 4 here. Okay. Because the list is length 4. But if you write this way, you will make a tuple and it will count how many you are sending. You are sending 1. Okay. If you have any doubt about this 4, why you got 4? 4 is the length of this tuple. But how many we are sending means we have sent only 1 list. Okay. We have sent only 1 list to A. 4 here length we are counting means length of the list we are counting. But here, if you make it a star here, this will no more be a list. Okay. If you have any doubt, I will write type of A. Now see, here type will be a list. You can't write more than one print. So see, type is list here. But the time I will write, I will add this one. What will happen is, first of all, this will make a tuple. Then this will count one element we have sent. So length will be 1. And finally, it's a tuple. You send a list, you send whatever, you get a tuple. See, the type is, the class is tuple, and we have one element here. This total is 1. You can make many and you can send to A. Is it fine? Because after sometimes we can't hear a lot, right? Yeah. In a classroom setting, if problems are given, then you can do and sort it out if you are doing for the first time. Anyway, so remember, if you write a star here, then it gives you flexibility. Okay. So whatever you write, now 2 here, and finally you are getting a tuple, and you have 2 here. Okay. The next one is keyword argument. Suppose I write double star here. This makes a dictionary. Okay. You will see how a dictionary looks like if you are seeing for the first time. We'll have one class for tuple and dictionary, combine one class. Okay, that's all. So how dictionary is different, this is called mapping. What happens is, when you write a list, we write this way: 10, 20, 30. This is a list. Just remember this much only. Then a tuple. Then you can write a set here. Then we'll make a dictionary. So when we write 10 here, if you write a for loop, you will be able to know. If you want to write A0, A0, we have index concept here. A0 is 10. Even you write a string also. You write a string here, Amit. So what happens is, if you print, you will get A0. By index, we try to access the elements. A0 is A, A1 is M, A2. If you denote it by A, A2 will be I, A3 will be T. In a list, this is A0, this is A1, this is A2. Okay. So here also, this is A0, A1, A2. In set, what happens is, it's a mathematical set. Okay. Again, for all these things, we'll have a class separately. We don't use that frequently. Just you write here. Suppose A is a set here. And if you print A, you will get set. But the difference is, suppose I write 60 here, and again 20 here. You run it. Most of the time, you won't get whatever way you write. Okay. You can write it rather and check. The difference is repetition is not allowed, and you can't capture the elements using numbers. See what it says: set objects is not subscriptable. There is no such concept here. So you don't write this. Again, remember, it's a set means repetition is not allowed. If you count the number of elements here, it's not 5. It's 4 here. You see, we printed here 1, 2, 3, 4 because repetition is not allowed in a set. If you don't allow repetition, initially you say this is 0 index, this is 1, this is 2, this is 3, this is 4. But then we have 20 appearing in 2 places, then that will create a problem. Suppose you have so many repetitions, okay, so that's the problem. Even there is no concept of the first one, second element, third element, nothing like that. Here you got in this way, but you might not get this way all the time. Okay, set is just collection. Whatever way we know in mathematics, the same way it's defined here. It's a collection of elements. That's all. That's a set, and repetition is not allowed. Suppose I want to write a dictionary. In dictionary, what we do is mapping. Mapping means suppose I have to write A you write. You keep 10 here. So we don't have index here, right? And you write B here. Then you keep 20. Then there's so many ways you can write, okay? Different ways we have. We can write equal to sign also. We'll go to those things later. Let me know if there is a problem. Yeah. So 10, 20, 30, 40, the set we got. And so this is a dictionary. More will learn later. So if you want to capture 10, these are called keys. A is one key, B the second key, C the third key. Instead of index in a list, you can get the element through keys. Okay. So A is mapped to 10. You can write this way. Again, if you go behind, I'm not going to those concepts here, hash, mapping, pointer, all those things. Though we don't use pointer thing here, unlike other programming languages. Hash mapping is there. It's not direct, but yeah, we can remember because we are doing something applied. B is mapped to 20. These are called values. And C is mapped to 40 here. So if you want to get 10, okay, you can get 10 through a key. Key for 10 is A, and key for B is 20 is B, and 20 is the value. Key for 40 is C. Okay, these are keys A, B, C. You can write D dot keys, you will get all keys, and D dot values, you will get all values. So if I write a list here, you can compare this way. Though we don't write this, you can compare this way. 0, the element is 10. Okay. Then 1, the element is 20. And then 2, and this is 30. 0, 10, and 120, 230. So what happens here is, this is the index of this element. Okay, so we get access to this element through this index. We get access to this element through this index. We get access to this element through this index, even way minus 1, minus 2, minus 3. So instead of these numbers like roll numbers in a class, we have names here, keys. These are keys here, and keys should be immutable. Okay, This is the main thing you need to remember. More will discuss, okay, in another class. I don't want to waste time for this. Maybe I'll send a recording later. But yeah, a lot of things we have here, and 2 months is a very little time, because again in the applied part, in the libraries, we have a whole lot of things in NumPy, Pandas, Matplotlib, Graph. Every library, if you import, you want to learn, it will take 1 month's time. That's why I plan this way. So yeah, let me delete all this. Now keyword arguments here. Okay, so keyword, suppose I use a key here, A is 30 and B is 50. Okay, this way if I do, I write a double star here. There is a mistake though. No, I've written here. So you see, finally you got the dictionary here. So suppose, let me write C here. Remember, in the last class I discussed about positional arguments and keyword arguments. We say keyword arguments if it's assigned to some number. Okay, if you simply write A here, then the problem is it will not be able to take B and C. Even if you write a single star here, then also it's not possible. Single star is capable of taking 3, 30, 50, 100 this way. But if you make it, that's why KW is here. If you write this way, okay, keyworded arguments, if you write this way, then if you write double star, then A is capable of taking everything, but it will make a dictionary. A dictionary will be formed. Okay, you run it, you get a dictionary out of it. Your numbers are there. Okay, if you want, you can get numbers, not a problem. How to get numbers? Because instead of indices 0, 1, 2, you have ABC. Through ABC you can get access to these elements, no problem. See, you wanted to get these elements, right? Writing only once here, you will be able to do that. There is no problem. X will take care. Okay, so here I wrote X here, and then I run it. Print length of A. Okay, AX. Okay, there is a problem, that's why. All right, so you change everything to X, because we use in different places. That's how we get the problem. So here it's capable of taking a lot, but remember, when you write a double star, okay, then it will make a dictionary here, and in the dictionary form it will be able to save all your numbers. And if you want to retrieve these numbers, yeah, through ABC you can get. Okay, like the name of the dictionary is X here, and you can print X of A, then print X of B, print X of C, or you can, if you want to get everything at the same time, you can write dot keys. Okay, you write print X dot keys. We don't need keys anyway, but if you want to know keys, you can know this way. If you want to get values, you get values. Okay, if you want to get print, you'll get this one. Okay, here in dictionary we have to write So 30, the first one is 30. This way we get. Instead of writing 0, we are writing only A. That's all. There is no difference, okay? And individual, if you want to get, you write B here, C here. So ultimately, what we wanted to take all these values, okay? But it will take in the form of a dictionary. That's what you need to learn here. So now let me write all types, okay? This is a function. I have a variable A here, and for that I will write 10, and then 30 here. I will write B here, okay? I have to write something, pass, whatever, okay? Print A, suppose. What happens is, here 10 is assigned to A and 30 is assigned to B. Suppose I will write something here again, 80. So I wanted to print B. This is called default value, okay? So initially it was 80, B was 80, but you sent here to the function 30, so 30 will be taken. Now write this. Default not allowed, okay? You can't write this way. You can start with a default one, okay? It's not allowed. You can check here. Non-default argument follows default argument. This is not allowed. So remember, the first one you have to keep this way, whatever way it is. The second one you can make it default, or you don't write anything. That's fine. Now then I'll write a star C. Then I will write double star D. Suppose you write 30, 40, 50, 60. How can you know what will go to A, what will go to B, what will go to C, what will go to D? D picture has not come here, because for that I have to write something else. So yeah, you can write print ABC and you can know that's a separate thing. But yeah, A we got, you print B. And you print C here. So if you print this way, see A 10 went to A and 30 went to B. And then because we have lot of arguments with one parameter and that too star is there, then everything will go to C. 3 things, okay? And it will make a tuple also, not only that. But if you make a tuple here, then you don't need a star. However, if you even if you write a star also, there is no problem, because this is capable of taking more, one or more. One also it will take, not a problem. If you write a star, it will make a tuple, that's all. Now this much is over. Then comes, suppose you want to write a dictionary, you write keyworded, okay? Suppose I'll write D is equal to 70, okay? And 1 2 3 1 2 3, okay? I have many, suppose, variables here. I have to write M, N, 60. So this is the order, okay? So if you do this way, I've written, I've added, sorry, I printed ABC, and Yeah, see, I printed A here, A is 10 here, and I printed B here, B is 30. I printed C here, C takes the rest here. Why not 70? Because the key worded started, okay? These are called key worded arguments here. So KW, see, if you want, I mean, many they write also, the full they write. It's not mandatory. The mandatory thing is double star here to the left, and here one, here one. So ME 70, NE 60. So yeah, you write M70 and N60 that way. So the rest, whatever keyworded you have, that will go here. Now suppose I gave 80 here, you run it. There is a problem, right? And what problem it says, if you write some variable t here, then also there is a problem. This 80 will not go to t. Okay. I'm not going deep into theory. You can remember certain things. Okay. The order, uh, you see, I will just cut 80 and I will take here and I will take here, then it will work. Let me write here. And this 80. Then because A will take 10, B will take 30, T will take 40. Then we have so many, one variable, that too we have a star here. So this will be taken as a tuple, and then keyword, this will be taken as a dictionary. So when you print dictionary, everything you get. If you want to, because ultimately you wanted to take two values, you wanted to print the values, you write d dot values. That's all extra you need to write. If you are not interested in the keys, it doesn't matter. See, ultimately we get values, okay? Whatever values you have, dictionary values, and here you get tuple, here you get whatever you send, that way. So the class ends here. I don't want to continue more. Yeah.